Okay, time to go home over your homework questions. So the first set was on page 513, numbers 26 to 29. And 26 talks about a muon, and you haven't actually met the subatomic particle of muon yet, but you don't need to know it. All you really need to know is that it has the same charge as an elementary charge, proton or electron. It tells you the force is 5 times 10 to the negative 12, and it tells you that it's moving 4.21 times 10 to the 7th meters per second, and it wants to know how strong a field. So you're going to use F equals QVB sine theta, and you're solving for B. So B equals F over QB sine theta. And in the question, it does not say anything. Oh, right angles, it does. Good. It tells you it's traveling at right angles, so the sine theta will be 1. So it just becomes 5 times 10 to the negative 12 newtons over your 1.602 to the negative 19 coulombs, and then times 4.21 to the negative 7 meters per second. So hopefully pretty straightforward. And when you do this, you get a B of, I believe it's 0.742. 0.742 Teslas, assuming I can make up my writing from when I did this. I think that's a 7 and not a 9. Next question, still the muon. This time it tells you it has a mass of 1.88 to the negative 28 kilograms, and it wants to know the acceleration. So you're just going to do F equals ma. So A will equal F over m. So A will equal the 5 times 10 to the negative 12 newtons that you got above, and divided by this 1.88 to the negative 28 kilograms. And you end up with an acceleration of 2.66 times 10 to the 16th meters per second squared, which seems rather huge, but it is an acceleration, not a speed. Okay, number 28 wants to know singly ionized, so that just means from chemistry, remember if it's singly ionized, one electron has been taken off, which means its charge is 1.6 to the negative 19. So singly ionized particle experiences a force of 4.1 to the negative 13. It's in a magnetic field of 0.61 Teslas, and it wants the velocity. So again, F equals QVB sine theta. This time you're rearranging for V. So F divided by QB. And looking, travels again at right angles, so the sine theta goes to 1. So 4.1 to the negative 13 newtons, singly ionized 1.602 to the negative 19 coulombs, and B is 0.61 Teslas. And so when you punch all this into your calculator, you should get something like 4.2 to the 6th times 10 to the 6th meters per second. All right, 29 was perhaps the only one that might have caused you a little bit of a pause to think, but probably not too much, because it asks for the number of elementary charges. It gives you force, gives you velocity, gives you B. So first you're going to solve for Q. So F equals QVB sine theta. So Q is going to be equal to F over VB. And again, traveling at 90 degrees angles, so the sine theta goes to 1. So we have Q is equal to 5.78 to the negative 16 newtons, and you're going to divide that by 5.65 to the 4th meters per second times 3.2 to the negative 2 Teslas. So you get your Q, and it works out to be 3.197 to the negative 19 coulombs. And then remember, number of elementary charge is just equal to Q total over the charge of 1. So when you divide the 3.197 by 1.602, you get something awfully close to 2 elementary charges. All right, the next set was over on page 553. And I screwed up. You can't do 5b yet. We will get there, but you need one more equation, so my apologies. All the rest are good, though, and they're all using R equals mv over qb. Okay, so it tells you in number 4, it's a proton. It tells you the field, it tells you the radius, and I gave you the mass of the proton back when we first started the review of electrostatics. Those of you that already took Physics 12, you have it from a long time ago. Those of you that are new, that are in Physics 12 now, it is on those review sheets I gave you, okay? So it's 1.673 to the negative 27, and in this question, you are solving for speed. Okay, so you're going to rearrange this for V. V equals RQB over M. So V equals 0.2 meters, 1.602, negative 19 coulombs, 0.36 Teslas, and it's all divided by that 1.673 to the negative 27 kilograms. And you get a speed of 6.8944 times 10 to the 6th meters per second. All right, number 5a, exactly the same idea, and again you're rearranging the R equals mv over qb. You're rearranging for v again. So RQB over m, again you're filling in your values. This time the R is 0.02 of a meter. Q is still 1.602 to the negative 19 coulombs. 4 to the negative 3 Teslas is the field. And this time it's an electron. 9. I couldn't remember if we did 1.1 or 1.0109. So I'm using the 109. If you used 1.1, it won't be off by very much. And yes, technically you could put a negative on this. It's just going to give you a speed with a negative, and that negative will mean use your left hand when you're doing the hand rule, because it's an electron that's moving. Okay, so if you want the negative here, it'd be here, and it would turn out to be negative 1.407 to the positive 7 meters per second. And this means electron, therefore left hand. Okay, number 7, exactly the same idea again. It's a proton this time, and this time we're actually looking for R, so you don't even need to rearrange it. mv over qb, and its mass 1.673 to the negative 27 kilograms. Its speed 5.4 to the 4th meters per second. Q 1.602 to the negative 19 coulombs, and B 6 to the negative 2 Teslas. Punch all of this into your calculator and get 9.3989 times 10 to the negative 3 meters. Okay? Oops, sorry, finger over the camera. All right, next one, number 8. Number 8 actually asks you for the circumference, but to find circumference, first you have to find the R. So mv over qb to get the R. So R will equal, it's a proton again, so 673 to the negative 27 kilograms. The speed this time is 4.5 to the 4th meters per second. Q 1.602 to the negative 19 coulombs, and B 6.4 to the negative 2 Teslas.